This is MathCamp321 presenting a question like number 23 from section 7.3 of your text, Geometry for Enjoyment and Challenge. If you follow along this video and are able to understand what's going on, then you should be able to then go to your book and do their version of number 23. Okay, this question states, 6 of the angles of a nonagon have measures whose sum is 1,000. Of the remaining angles, exactly 2 are complementary and exactly 2 are supplementary. Find the measure of the remaining angles. Okay, let's read this again. There's a lot of words here. Let's read it again from the beginning and really dissect it and try to draw some conclusions along the way. 6 of the angles of a nonagon. So the word nonagon tells us that we have a polygon with 9 sides, so n is equal to 9. Now, they're talking about the measures of these, the measures of the angles of this nonagon. So this brings to mind a formula, S sub I is equal to n minus 2 times 180. Now, in this case, we know that n is equal to 9 because we have a nonagon. Of course, 9 minus 2 is 7. So we have 7 times 180, which is 1260. Okay, now this is where it gets a little interesting because all of the angles together add up to 1260, but 6 of those 9 add up to 1,000. So the first conclusion we can draw is that if they've addressed 6 of the angles, that means there are 3 angles remaining. And for convenience sake, let's call them A, B, and C. And if the first 6 add up to 1,000, then the remaining 3 need to give us the balance of 260 to give us that total of 1260. So this is going to suggest an equation. A plus B plus C equals 260. So that first sentence really gave a lot of information to us. Now the second sentence begins with, of the remaining angles, exactly 2 are complementary. Now complementary means adds to 90. So let's take any 2 of these remaining angles. I'll take A and B. And they're supposed to be complementary, which means they add to 90. Okay, and if I keep reading, it says, and exactly 2 others are supplementary. So I'm just going to use, for convenience sake, B and C. Now supplementary means adds to 180. So what I've essentially constructed here is a 3x3 system of equations. Kind of challenging. But the method to solve this isn't actually so bad, especially if I use the substitution principle. So the first thing that I notice is that A plus B is in the second equation, and A plus B is also in the first equation. So what I could do is I could take that top equation, and instead of saying A plus B plus C equals 260, I could replace A plus B with 90, and say 90 plus C equals 260. And if I subtract 90 from both sides, I get C equals 170. Now my objective was to find the 3 angles, and I've now found one of the 3. Now if I go down to the bottom equation, it says that B plus C is equal to 180. But I just found out what C is, and C is 170. So I could say B plus 170 is equal to 180. And if I subtract 170 from both sides, I get that B is equal to 10. Now that I know what B is, I can take that answer and plug it into the middle equation, and then I can get what A is. So A plus B is 90, or A plus 10 is equal to 90, which means if I subtract 10 from both sides, I get A is equal to 80. And as a double check, I can just think about the parameters given on A, B, and C. These angles are supposed to add up to 260. 80 plus 10 is 90. 90 plus 170 is 260. So that condition has been met. 2 of the angles were supposed to be complementary. And if I take A and B and add them together, they add up to 90. Those are complements of each other. 2 other angles are supposed to be supplementary, which means they add to 180. If I take B and C and add them together, 10 plus 170 is 180, so that condition has been met. In fact, all the conditions have been met. We have successfully found angles A, B, and C. Now go to your book and try their version of number 23. I hope this video has helped.